So for example, if you had to put like, if we had to, give me some conjugate bases of weak acids. Well, here's a good one, F minus, right? That's the conjugate base of HF. Give me another one.
CO, no.
Acetate. Just give me one more.
CO.
Do I have nitrous acid on? Yes, so nitrite. You said nitrite, right? Okay, those are all conjugate bases of weak acids. Which one of those would be the strongest base? How do you do that? So look at the acids HF, HC2H3O2, and HNO2, and look at their Ka values. What is the Ka of HF? 7.2 times 10 to the negative 4. What's the Ka for acetic acid? 1.8 times 10 to the negative 5. And for nitrous, 4.0 times 10 to the negative 4. So of those three acids, which one is the strongest acid? Is everyone in agreement about that? So strongest acid, and then the next one?
HNO2.
And then? Okay, so then over here, which one of these would be the strongest base? 1, and then 2, and then 3. So this would be acid strength, and this is conjugate base strength. They are opposite. So the stronger the acid, the weaker its conjugate base. So a lot of times you'll be asked to put these kind of bases in order, and you'll be given the Ka values of the acids. Careful with that one. Okay. All right. And that's just the opposite of that. Okay, so make sure that you know this, pKa. Sometimes you'll be given the pKa instead of the Ka. How do you find the pKa? Like if I tell you this is the Ka value for HF, how do you find the pKa? How do you go from Ka to pK? Yeah, take the negative log of it. So take the negative log of 7.2 times 10 to the negative 4, and that is the pKa for HF. Sometimes you'll be given those to compare instead. Be careful with that. Let's look at the pKa's. Yes, Barry.
How do you go back from that? Why do you do pK?
Then you do 10 to the negative that. 10 to the negative pKa will give you Ka. Good question. So for these three, tell me what the pKa's are. And this is where you have to be careful. So what is the pKa of HF? Yes, pKa is 3.14. What is the pKa of acetic acid? 4.74? That one is one you will see a lot. And what is it for the last one? 3.40. So sometimes you'll be given them like that. Sometimes you'll be given the pKa's. And then, actually, I think it's a little bit easier to compare acid strength if you're given the pKa's instead of the Ka's, because then you can kind of look at these and you can see right there. But be careful, because if you're looking at pKa, the smaller the number, the stronger the acid. So be careful with that if you're given pKa instead of Ka. Why is it that way? Because it's the negative log of it. We're taking the negative log, so kind of think of it like pH. The lower the pH, the more concentrated the acid. Sometimes also stronger. Okay. You guys okay with that? Oh, here's a question on your phone. Without looking up there,
What I can get.
list strong acids. See if you can list. Oh, what? Oh, a minute. Don't try not to look at that. Ka is the the equilibrium acid dissociation constant of a weak acid. Could be of a strong acid too. But so an equilibrium constant, like if you write out HA, which I erased it, this one here, HA, dissociates into H plus A minus, and you write the equilibrium expression for that. It'll be H plus times A minus all over HA. That's equal to Ka. It's called Ka. It's not Kc, it's not Kp, because it's of a weak acid, is the acid dissociation equilibrium constant, usually just referred to as the acid dissociation constant.
So then how did you get 3.14 on everything?
That's pKa. Take the negative log of the Ka value. And sometimes it'll be given to you in that form, yeah. Sometimes it'll be given to you like that, so you're looking at whole numbers instead of weird exponents. So, oh, okay. Yeah, are you guys looking? Oh, nice pictures. Oh no, one of them is one that isn't one.
Hey, I'm done. I'm just saying.
Oh, all 6.
We did it all.
Except you put one that isn't right.
That's awkward. What?
Very.
Oh, I didn't I?
Yep, you put HF in there. And I see an H2PO4. I see an HF.
Oh, the
See, one
PO4
person
was
only
mine.
put 2.
Okay.
I might have to put H2SO4. I think we're
I entered the wrong scheme. I wonder if I could enter just a random pin and get another class.
I don't know.
Oh, I just told Davis
You'd
one.
have to be able to guess one that's actually active right now. That one has an interesting picture in it. I don't know what that
Yeah,
is.
we should do a quiz over.
Yeah, we had one last year.
No.
Yeah.
That'd be good.
Yeah. Okay, I'm gonna move on. You guys, no? You want a second segment? Here, we get to do a practice problem. Oh, that's cute. Okay, I'm moving on. So I put the last slide on your phone if you want to remember that, if you didn't get everything. Okay, this is a question that has come up in a very similar form twice recently. That's kind of weird. Listeners telling you, like, usually we're dealing with 25 degrees Celsius, but some of the ones that are not at 25 degrees Celsius are more of like a thought question. So I don't want you to say it out loud because I'm going to put it on here. The picture of the question is now on your phone. I'm going to leave it up here, and in just a second, I'm going to move forward. So if you want to get a picture of the question, I'm going to move forward because it's not. I don't put these. I'll make my own because I'm not supposed to. So in just a second, I'm going to let you answer it.
Why don't you just reset?
Well, I do. I only have to move it forward on here. I just want you guys to think about it, and then I'll talk through it. So I'm going to let you guys try to guess and see what you would think, and then I am going to talk about why it's the answer that it is. Okay, so I don't see many right answers in here. Let's see. There's some.
It's probably T.S. and David. Or A.S. Maybe it's P.S. I've been tracked. That's a good question. It's a good idea.
Go half and half right now.
Oh, dude, she just did attack now.
I do like that. I don't know. There's two that you guys. You guys are all torn between two answers up here.
See?
Yes.
Uh-oh.
Only one person has an answer. Almost. Okay, more people got it wrong than right. So I'm gonna talk about it. Okay, it's D. Okay, so look at this for a second. Remember we talked about what is P at 25 degrees Celsius? What is PKW?
Super hot fire.
14. And that equals what plus what? but it doesn't. 14 equals pH plus POH. And if it's pure water at any temperature, what do you know about the pH and the POH? They will be equal. They will be in pure water. They will be equal to each other. Okay? So here, like, what's the pH here?
Lower.
No, what's the pH? 7.1. Here, what's the pH?
6.9.
Yeah, 6.9.
Good
And
try.
what's the pH here?
That's pretty cool.
So what's happening to the pH?
It's going down.
It is decreasing, and what's happening to the temperature?
Going up.
Yes. So as temperature increases, the pH of the water is decreasing. So is everybody kind of okay with that? Different variations of this exact same question come up. Alright, so there's the answer to it. We're going to move on to pH of weak acid solutions and do some problems. Are you ready? That'll be a yes. Alright, Ka values are going to be small. And the smaller the Ka value, the what? Smaller the Ka value,
The smaller the disassociation rate.
Oh, you're right.
there's some interesting answers
Is
I'm
that
giving.
it? That's it.
The smaller the Ka value, the weaker the acid, and
Yeah, that's right. I was right.
the
I was right.
stronger the conjugate base. Yeah. Yeah. Okay. Always write down the major, and you will see this. Sometimes they will ask you, what are the major species in solution?
small caps.
And the species will always be the actual acid itself, and then the H plus, and there will also be OH minus and A minus. So from the very beginning, every single one of these is going to be an equilibrium problem. So you have to figure out, is most of the H plus going to come from the acid or the water? Usually it comes from the acid. You just have to decide how low is the concentration of the acid that you're starting with. So you compare Ka and Kw. For which of these, and are there any, for which of these that are on here would water contribute more to the pH than the acid? Hypochlorous acid? Yes, hydrosanic. Ammonium. There you go. All those in order there. Because the H plus concentration for all of those is going to be less than that. Okay. All right, everything else for all of the other problems is going to be just like the last chapter. It's all going to be an equilibrium problem. Ice tables. That's it. All ice tables. And again, they're all going to look exactly the same. So don't get to the point where you're like, oh, I already know it, and try to guess. Be careful with these. So we're going to try a problem. Here's the first one. Calculate the pH of 2.0 molar acetic acid as a Ka of this. I'm giving you the Ka. It's also on your pink sheet, but that's all you need to be able to tell me the pH. You could also tell me the POH, the OH minus concentration at equilibrium, the H plus at equilibrium, but you have to do what? You have to do what to be able to figure this out? Ice tables. That's right.
Sorry, I just can't help myself.
You know vanilla ice.
I feel the same way. I always want to sing it too. So do you want me to do this one with you, or you guys want to try it on your own?
Do it with us.
Okay. Let's try one more
It's not even lived up to the challenge.
All right, so I'm just going to write HA because nobody likes to write out acetate. I'm not going to do that black there because you can't see that.
Do you?
Yeah.
I'll just wait for you.
Okay.
No.
So I'm going to say HA dissociates into H plus A minus, and then Ka equals H plus times A minus all over HA. And all of these values have to be what? Numbers that are what? Yes, and also they don't have any zeros at the bottom, so they're all the numbers that are what? At equilibrium. So that's why you're supposed to do an ice table, because you have to figure out what are the equilibrium values for all these. And it's always going to kind of look the same. This is 2.0. What are these both going to be? 0. And then this will be minus x, and now these will both be plus x.